All right, let's get started.
You need a liquor sponsor on this show. That's what we need.
Hello, everybody. Welcome to OpenCV Weekly Webinar. And today we have with us Ritesh Kanjee, who is the CEO and founder of Augmented Startups. He has a YouTube channel, very popular YouTube channel, and he has been producing amazing YouTube content. So welcome, Ritesh.
Thanks, Satya, and thanks for having me.
Great. And we also have with us Phil Nelson, who is the content manager at OpenCV. He is responsible for putting together these webinars and a lot more. Hi, Phil.
Hey, welcome back, everybody. Yeah, thanks again, Ritesh, for stepping up here. It was supposed to be Joseph Nelson of RoboFlow. You know what they always say, never trust somebody from Iowa. Joseph's loss is our gain. This is going to be a really fun episode. I know you folks tend to like these tutorial type episodes, and so do we. So that's great. As if this is your first time joining us, we do a giveaway after the presentation here, so stay tuned for that. Ritesh has been kind enough to offer 5 free courses for either YOLO R or YOLO X. Is that the giveaway, Ritesh?
Yeah, it's the YOLO X, which is still coming out. That'll be released hopefully by Black Friday, and then the YOLO R course, which is already out.
Awesome.
That's great. And the first question is, which brand of water? Actually, no, I was just kidding. Let's.
Yeah, that's going to be my question for the end.
Right.
Yes. Also, we'll be doing Q&A from you in the audience during the show here. So please, at any time during the webinar, use the little Zoom Q&A button down at the bottom of your screen and ask your question. We'll do our best to get to it at the end of the show, or if it's contextually appropriate, maybe during the presentation.
That's great. So let's get started with the presentation.
Cool. So just a little bit brief about who I am. My name is Ritesh Kanjee, for those who don't know. So I started out as an electronic engineer doing PCB design. I know it's far from computer vision. What happened was when I finished university, I realized that there was a really big gap or disparity between what I learned in university and what was expected of me in the job market. So eventually I managed to get a job, and then there was a lot of challenges along the way in just like keeping up and maintaining a job at that time. I'm sure a lot of people know that there's a learning curve that's involved. So I decided to document these challenges that I overcame, and unlike instead of doing it normally in a document, I decided to rather create YouTube videos, or just videos of these tutorials. And then it was about a couple of months later, I realized I had all these videos, and if something had to happen to my hard drive or my computer gets stolen, all these videos would be lost. So it was from there I decided to upload them to YouTube under the alias of Arduino Startups, because I was teaching Arduino PCB design at the time. And then I realized, okay, what became 1 view became 10 views, grew to 100, 1,000, and eventually now it's around 7.6 million views in total since inception. Thanks, with around 92,000 subscribers. And currently, I changed the name from Arduino Startups to Augmented Startups, mainly because I was switching from Arduinos to augmented reality, and now I switched to computer vision and focusing mostly on that.
Hopefully, you can return back now with the Meta. Facebook changing its name and focus to Meta. I think augmented would work just fine.
Meta Startups. Or I could even do what NVIDIA did, which is call it Omni Startups, because they have the Omniverse also.
Right. So you don't have to change no matter what happens. You never have to change. So while we are at this topic, this is your full-time, this is all, this is your full-time thing, right? You don't have a side job or anything. This
Yeah.
is your thing.
So I was working for the past 9 years. I had augmented startups as a side hustle for around, say, 5 to 6 years. And that was my side hustle until this year of April. Actually took the leap and made it my full-time job. So I'm quite happy.
Congratulations. Congratulations.
Thank you.
And
computer
for
vision
those who
full-time.
for those who don't know, Ritesh is from South Africa. So you can imagine, people from all around the world can now participate in this kind of global economy, right? You don't need to be in a specific region. So it's very inspirational, frankly. I mean, you have made a name for yourself, and your tutorials are very, very entertaining, right? It's impressive.
Thank you. I really appreciate it. I always try to keep things fun, and helping others out in the same problems that I had when I was overcoming my initial challenges, and trying to close the gap between what people learn in university and what is expected of them in the job market, mainly with regards to computer vision and stuff like that.
All right. So are we ready for the presentation?
Yes. Let me share my screen and then get started. Can you see my screen? Everything is good? Okay, cool. So today I'm going to show you guys how to build a computer vision product. Okay, it's not going to be step-by-step tutorial coding and stuff like that. It's just too much to cover in one webinar. I'm just going to show you more or less the process that goes into building a computer vision product. Especially if you're just getting started out in computer vision, or maybe you have some computer vision skills, but you want to know how to take it to the next level. This is mostly the reason for this presentation. As I mentioned earlier, my name is Ritesh Kanjee, the CEO and founder of Augmented Startups. I qualified as an engineer with masters from the University of Johannesburg, currently with around, say, 92,000 subscribers, trying to get, it's basically crawling towards 100,000.
Nice.
It's very, very slow at the moment, but getting there. So first off, let's define what is a computer vision product, right? If you look at this, it looks nice. You can implement some OpenCV functions to get maybe some outputs from it, like tracking, vehicle detection, tracking, count how many cars are in and out. You can also use it in this setting where you can get total traffic amongst many others. So this is all great. Some people would call this a product, but I would actually label it as not great example of a computer vision product. You'll see why in just a bit. So if you look at this example over here, so you're doing more or less the same thing as the previous one, where you're implementing computer vision on, or object detection on certain objects of interest. And what's really nice is that you have a user interface, you've got a dashboard, you can monitor everything, everything's visually appealing. And then you got graphs, nice user interface, buttons and stuff like that. That all makes it so that anyone, almost anyone can operate your product without having to know too much technical knowledge. This is another example. It's not as neat or visually appealing as this one, but it still has functional elements like graphs. You can input some time and date, so that's great, and gives you some key information over here. Here's just some other examples. This is the one I like quite a bit because it tells you, okay, there's a distribution of cars to trucks to buses, how many pedestrians there are, vehicles. It tells you how many, it tells you the parking occupancy over time. So you can say, if I want to get a good parking spot, I need to be here between 3 p.m. and 5 p.m. Before peak work hours. So You can also check the vehicle count by zone. And what's really nice is that you can also map it onto like a GPS geolocation and say the density of cars in this area is much more than this area, for example. This is another example.
If you look at the venture capitalists, if you ever go to venture capitalists to raise money for an idea you have, one of the key things when they reject you, there are two things they say. One of the things they say that, oh, this is a $10 million idea. Actually, before that, when you reach and you're very early stage, they'll say that this is a feature, not a product, right? Which they mean exactly what you showed, right? That, oh, it's one thing to show a piece of technology, but then the product is much more than what what that piece of technology does. It has to be packaged well. And then you go back to them again, and then they'll say that, oh, this is a $10 million idea, not a $100 million idea or $1 billion idea, right? And that's just a way of saying that I don't like your product. Yeah, I mean, not to be pessimistic about it, but I'm just saying that, those are the phrases VCs throughout, very standard phrases, right? The first time you hear, the first time we heard with my first startup, oh, it's a $10 million idea, not a $100 million idea. And I was so thrilled. I was thrilled at that rejection that, oh, this VC thinks that my idea is worth $10 million. Right? So what, he rejected it. And then the next one said the same thing. And after that, they said that's the same thing. And then I said, this is just a way of rejecting. Sorry, we got diverted. Go on, please.
No, it's cool. It's people try to cover up the bad with something that sounds good.
Right.
Yeah.
The medicine go down, as Mary Poppins said.
True. So back to the examples. This one I really like with regards to its user interface or just how it looks, is that we can overlay heat maps onto the computer vision dashboard. Like, say you obtain trajectories like over here, you accumulate them over time, and then you can say, okay, in this lane, there's a lot more traffic than this lane here or this lane. Maybe we need to do something about the traffic. Maybe get the traffic a traffic light to activate at this point, or maybe build more lanes or stuff like that. So good things about a good computer vision product will give you the analytics and insights that will help you to either cut costs or make money. So that's essentially the goal of creating a computer vision product. So your next question must be, okay, how do I go about building a computer vision product, right? So first, you may either start off with a single image. Maybe you don't need real time. Maybe you just need a single image to perform inference. Or if you want a sequence of images, you could have a video sequence or video sequences from multiple sources. And that would go into this sort of, not a black box. It'll be sort of like a process. And you'll start off by implementing first object detection. I'll explain in a bit all these terms for those who are new. And then from object detection, you would implement object tracking, and so that you get tracks of each and every object of interest that you are currently tracking. From there, it would go into a sort of analytics engine. So this would refine all of your key analytics that you've obtained from your computer vision elements over here. And either you could take it as raw analytics or raw numbers, or you can perform some sort of data science or some magic to it to get key parameters that would be insightful for the end user. And then finally, we package it all together into a nice product that you can, or like a dashboard that is visually appealing, and people would want to look at it rather than looking at the Python terminal. Yeah, that tends to happen sometimes. Okay, so just going on to what is object detection, right? Simply put, it's detecting objects. In this case, I'll show you a demo a little bit later on as to how I used object detection to determine what type of cards they are, or just the different card types. So in this case, it would be King of Clubs,
So,
and here would
Ritesh,
be Ace of Diamonds.
hold on 1 second. So I saw your water, the thing that you call water. Basically,
You're talking about
Ritesh,
this one, yeah.
so we went from alcohol, now we are going to gambling. All right, things are moving in the right direction.
Okay,
Let's keep
wait.
going.
I got my cards there.
You got your
bring,
cards, you got
Paul,
your
Paul,
alcohol.
do you have the poker chips there?
That's right.
Yeah, so maybe we could even put this in a hat, like a discrete hat. I would think that we could use the OpenCV AI kit, mount it into sort of like a hidden cap, and then see if we can win at a game of poker or blackjack.
Great way to get kicked out of a casino with extreme prejudice.
Yeah. Hope the government's not and the casinos are not watching. Yeah, so we could do some sort of object detection of cards themselves, but obviously the applications are quite fast. Looking at the types of models that we would be looking into, there's many types of object detection models. Like there's ResNet, Efficient Det, SSD, which stands for single shot detector. There's also FRCNN, fast RCNN, faster RCNN. I'm not sure if there's more beyond that, probably is. And the ones that I like to use is YOLO. Now, most people who have worked with YOLO know that there's YOLO V1, V2, V3, V4, V5, and maybe eventually we'll get to V10 million. I guess just kidding. There was a little bit controversy with YOLO V5. So from there, things went from instead of versions to alphabets. So that was YOLO R, which was the recent one, and it's also YOLO X.
Right.
I mostly use these two for all my computer vision projects. And if you look at my LinkedIn, there'll be a lot of demos on YOLO R, just YOLO R and Deep Sort for tracking. I'll show you that in just a bit.
That's great. So explain a little bit, we know that until, YOLO V3, it was very clear there was a single branch of YOLO. So YOLO is one of the most popular object detectors in the world. It is a single shot detector. And until YOLO V3, there was no controversy. It was maintained by the same person. And YOLO V4, and the inventor of YOLO, Joseph Redmond, he just left computer vision because I mean, in his own words, he's concerned about the
the ethical uses of object detection,
of object detection and computer vision in general. For example, people can use it in casinos. For example, people can use it in casinos and whatnot, but I'm joking.
Yeah.
But then came YOLO V4 and YOLO V5, which was not by him, but YOLO V4 was at least in the same, using the same branch of the GitHub repository. But YOLO V5 was completely different. So there was a lot of controversy around it. And now we have YOLO R and YOLO X. Tell me a little bit about how, did you see in your experience a bigger improvement with YOLO R and YOLO X compared to YOLO V4 or V5?
Yeah, so just expanding on what you mentioned, having it as YOLO V5 would imply that it's better than YOLO V4, but that wasn't exactly the case. Maybe over time they may have improved it, but that was then. So from my tests, I found that YOLO R is way more accurate than YOLO V5 and YOLO V4. I think even Alexei Bachowski did some tests with scaled YOLO before, and it also beat that in terms of accuracy. In terms of speed, it does get real-time performance, say about 15 frames a second on a 1080 Ti. But YOLO X is good in terms of its accuracy as well, but a bit more faster. You got different models. So you got the extra large, medium, and small, and also the nano, which you can run on maybe Raspberry Pis and stuff like that. So yeah,
so one of the
actually
surprising
enjoying using
things, for example, we noticed, it came as a surprise to me, is the tiny version of YOLO V3 outperforms the tiny version of YOLO V4 on standard benchmarks, which came as a real surprise to us when we were doing this. Yeah, and you can find these things on modelplace.ai. Many of these, object detectors are part of our standard benchmark, so you can check it out there.
Yeah, I'll drop a couple links in the chat here for folks.
Yeah. So just moving on to the next slide.
So just to summarize, you like YOLO R better than, in your experience, you like YOLO R better than YOLO X. Is that what you just said?
So YOLO X, I'm starting to like YOLO X quite a bit now because I just started working on it, and it's not only fast but accurate. So YOLO R is if you want like the best accuracy, and YOLO X is if you want speed as well.
Okay, so you have the option of going to lower accuracy and higher speed with YOLO X.
Yeah, exactly.
The standard model, at least. Yeah.
Yeah. So now if you want to train it for different types of cards, so you made your mind up, you want to go to Vegas, and you want to try your luck with some computer vision models to see if it works. You could train a custom model using RoboFlow, where you collect the data set. So what I did was I just took my webcam. I had someone to annotate it. You can annotate it yourself, but it's much quicker to have a dedicated team to annotate for you.
Yeah.
And also the cost per annotation is cheaper if you outsource it.
Right.
Eventually we'll get to a point where we can automate it using AI, but until then, maybe even using synthetic data sets like what Gerard Espona from Coda. Yeah, so eventually we'll get to that point. Next,
isn't it relatively straightforward? Let's say you are dealing with only one set of cards, right? One pack of, let's say, some standard pack of cards. I don't know, Bicycle or something, the brand very popular in the United States. So in that case, I was thinking, if I built this thing, one option would be to put this card on a green screen, right? With a green background and take a picture of it. And then you get the four corners. So you get the, you compute homography and rectify it. So for each card, you now have this very pristine looking thing. And then you can overlay, if you want to get, one card on top of each other, then you can completely do it in a very synthetic way, right? So you took, 52 pictures, and that's some work, maybe I'm guessing that it will take you a couple of hours to do this and write the code for rectification. But once you do that, it opens up so much, you can do all kinds of, you can occlude parts of this thing by, superimposing these things one on top of each other. Did you do some of this? Did you think about it?
Thanks for bringing that up. So in addition to the images that I labeled manually, that I got someone to label for me, I also had a synthetic data set that was generated. So you take pictures of 52 cards, and then there's a background. You just swap out the backgrounds with multiple images and stuff like that. And that generated, I think, about over 10,000 images of cards.
Nice.
So for anyone interested, my data set is on RoboFlow. You can get it downloaded for free, train it, and use it. Yeah.
So you have a data set of playing cards for about 10 with about 10,000 images that's on RoboFlow people can
Yeah.
download? Oh,
I
that's
think it's
awesome.
10,000. I think I'll just have to double check, but it's a lot of images that you could get some really great results just using that data set alone.
Oh, that's awesome. I mean, that's a very good
Mm,
start for most people, free
exactly.
data.
But
And
check.
what's cool is that I also took it and augmented it. So I'll tell you that about that. Foley, had something that you wanted to say, or no?
I just dropped the link in the chat for folks. So go ahead and check if you're trying to find the link to the playing card data set, it's in the chat now.
Yeah, on RoboFlow Universe. Yeah, so I took the cards, the synthetic data set mixed with my own data set. It may have a problem detecting cards that are non-standard images. Like say if you got like fancy images, it might struggle on that. But it works for most bicycle cards, and you can probably add on to it in RoboFlow if you want to cover all possibilities.
Right.
And then Satya mentioned that you can black out parts of the image, like if you want to black out maybe the card, like maybe one of the diamonds or one of the numbers, for
You could also
example.
occlude it as a real life situation, right? One card with the other. That way,
Yeah,
that's a more realistic scenario when you're putting the cards on a table or something like that. One card occludes the other, so you're able to do this.
yeah. But what I did is I created some logic. You'll see in my Blackjack card counting app, I've managed to occlude, eliminate duplicates for now. It won't help you in the casinos because if they have multiple decks, it's going to be a bit confusing.
Right.
So if there's duplicates, it's going to be a bit of a problem, but maybe someone can pull up upon that. So the organized part is where you'd pre-process or clean your data set and then use data augmentation to multiply your data set for training. And over here in the training part, I have a ready made YOLO R Google Colab that you can use straight off the bat. I show off in my course how to actually run it step by step and that. And then once you've done that, once you have your train model, all you have to do is you can either run it in RoboFlow or you can download it and to run on your YOLO R Python script that you have, either running natively or in Google Colab. Moving on to object tracking. So there's a lot of things that you can do with tracking alone. But before I get to that, let me mention some of the popular object tracking algorithms. But before I do, object tracking is essentially tracking each and individual objects of interest and monitoring where they are within the image and seeing basically understanding their behavior within the image. So there's a common misconception that you need to train the object tracker. For some cases you have to, for other cases you may not. Like with deep sort, you don't have to train deep sort. You can just plug in any YOLO model in, and whatever you trained with YOLO, like YOLO R, it will take what input is from the YOLO R model and then track those objects. There's also MDNet Fair MOT or FairMot, which is quite good. And the recent one, which I really want to try out, I've read the paper and it's quite impressive. It's called Bike Track. It seems promising, but I definitely want to try it out before I report on it.
Right. And just to add a little bit flavor to a little bit color to the object tracking idea, when in computer vision, there are two different kinds of things which are both called object tracking because they are object tracking, but the ideas are fundamentally different in the two. One is in classical computer vision, when we tracked an object, so you detect the object in one frame and then did not detect it in multiple frames. You track the object in subsequent frames and maybe did the detection every 10 frames or maybe every 30 frames or so. And in that, the challenge was modeling the appearance of this box right, as it goes through the frame. So a person can change the appearance, but you could look at color histograms. You can do, the basic, some gross values like histograms may not change as much, right? That was the idea. So you could track across frames. In many deep learning based approaches, what they do is, you actually detect in every frame, but you get a bunch of bounding boxes, right? So it's, for example, in this picture, you would see that, there are so many bounding boxes corresponding to all the vehicles. So the challenge becomes it's a track finding algorithm then, which bounding box in the first frame corresponds to the collection of bounding boxes in the second frame and the third frame and so on, right? So that's a different way of thinking slightly, where you're not necessarily modeling the appearance. You don't care how the appearance changed. You're just trying to see that, we have a collection of rectangles in first frame. We have a collection of rectangles in the second frame. Which one actually corresponds to which? And there could be a modeling inside it to a certain, you could have the trajectory of the object, that, this this object was moving such, and so I can predict where it should have landed, and I'll take the closest bounding box to it. But you could also model appearance inside it, right? So similar but different concepts, slightly, which achieve about the same thing. I hope I did not confuse people with that.
Yeah, there's various different methods to object tracking, and you get your sequence-based models, and then you also get your appearance-based models. You could also combine it with maybe like LSTMs eventually to get a better object track. But one of the biggest problems that is faced by object tracking is number one, occlusion and re-identification when the person moves out of the frame and then comes back into the frame. Or gets hidden by another object. So those are the challenges that object tracking is trying to solve for.
Right. And one of the earliest applications of object tracking was actually missile tracking. This was not a visual tracking, but when you had guided missiles, etc., they would send out their location, but it was very noisy. Sometimes you would not receive the location and things like that. So you had to make a prediction on where the object might be and things like that. So that was one of the original Kalman filter was developed for that reason.
Motion-based methods.
Yeah.
So some of the key information that you can get from object tracking is the speed of the vehicle. So you can see when it crosses this line, the speed. This is just approximation. It's not that accurate, but you can get the speed, you can get the trajectories, where are they moving north, south, and from this, you can also build up a history of all the vehicles that are over here, that are in your frame over time. And from there, you can either get the behavior of individual objects, or the behavior as the whole ecosystem, or the swarm of objects, as we say. From there, it goes into the analytics. And this is where you take all of your computer vision's key information and either process it into something that's understandable or makes sense, maybe using some data science to understand more about it, or you can just take the raw information like the total number of cars or real-time inference of cars. Also plot it against over time and see, okay, there's more cars at 12 o'clock or less cars at midnight, for example. What's good about this is that it allows for on-demand access of the most important metrics. That's what we want to highlight. It allows for better data transparency and understanding of the data, so that we are able to have better decision-making. If you know that, okay, if you're monitoring a certain place and you know there's a lot of people at this point in time, maybe you can make the decision to either stay away, maybe because for COVID reasons. And the goal, as I mentioned, is so that a person or the user can take action on those analytics. I like to call it action analytics. because dashboards are nice. People say, okay, let's build a dashboard, but then you end up with too many dashboards. Rather try and minimize it into something that's minimal and can inspire action. So one way you can do that is also by gamification. And then once you have all of those key analytics, you can wrap it up into a nice user interface. So this is where UI and user experience comes into play. And there's various ways of wrapping up all of the insights that you gather from your computer vision model. So I started out using Streamlit. Streamlit is very simple and easy to use. Get started. All of it's done in Python. So if you want something like a easy POC or proof of concept or minimal viable products, you can use Streamlit, and then all of the checkboxes and widgets are all there for you to implement quite easily. Blockly Dash is a little bit more advanced in the way that it has graphs, very nice graphs and stuff like that that you can implement. If you want native implementation, you can do something like Tkinter or PyQt. PyQt is quite widely used, also cross-platform. Otherwise, if you decide I just want to build a nice web application that can be accessed from different places, you can get your hands dirty and maybe create a web app using maybe React or Bootstrap or something like that.
So one of the things that I like to say, in the current scenario, people used to say that, oh, you should never be the jack of all trades and the master of none, right? That was the expression people used to use. But in today's world, if you want to build something all the information is available, all the tools are available. The right approach is that you should be the jack of all trades and a master of one, right? So have expertise, very deep expertise in one, but you should have all these other things also that you can play with. So a computer vision engineer who also can build UIs has such a big advantage on top of people who cannot do these, right? And doesn't have to be, they don't need to be experts in UI building or anything. They should be able to put together something very quickly, right? With minimal knowledge. And that person, that kind of people, they are always going to be in great demand in today's economy. Yeah. Otherwise, the things that used to be done by a team can now be done by a single individual, right? You do need deep expertise in one field, otherwise, you'll not be anywhere. So have very deep expertise in one field, but also have enough experience in all these other things that make a product possible.
Exactly. I almost felt like I was like the jack of all trades because I was doing PCB design, FPGAs, augmented reality, computer vision, until I decided to focus on just one thing. It's nice to have all of them, but sometimes also have.
I mean, you'll be surprised. You're still very young. As you grow older, you will see that those things will come together at some point. You would be doing some project where your knowledge with other things will come into play, and you will build a better product because you had this other experience.
Yeah, it actually helped me quite a bit with regards to my computer vision drone. I'll show you that a little bit towards the end of this webinar. But I think let's finish up on this computer vision product, and then we can get to the fun stuff.
Yeah, let's roll.
Okay, cool. So this is the computer vision that me and my team built. It's a traffic flow management system. This is actually what we're going to be teaching in our YOLO X course. So this is the first time I'm showing this to everyone, where essentially we're going to take all the computer vision models, like we're going to use YOLO X, maybe different types of models like YOLO X, large, extra large, or small and nano, implement that with some sort tracking. We want to implement byte track for tracking, but that will come maybe at a late stage. So essentially, what we have here is we can detect how many vehicles there are this minute, total amount of vehicles, frames per second, the resolution. We can put any analytics over here, and then we can accumulate this analytics to say traffic per minute to see either the real time or the cumulative traffic flow. We can also see which direction. If you're at an intersection, you can see, okay, there's a lot more cars flowing south than maybe north, for example. Then everyone's going to work. And then you can also see the different vehicle types to say, okay, there's more cars on the road than motorcycles or buses or whatever. And what's really nice is that we use Plotly Dash for this here. So you can click on each one. This is called Sunburst pie chart or Sunburst charts, where you can click on it and it will open up another section, and you can get some deeper analytics into that. So I'm really excited for this course that's coming up. Cool. So now we are at demo time. Are you guys ready to see the live demo of my Blackjack card counting?
Can we avoid Murphy's Law once again? Whatever can go wrong will.
Let's see how it goes. Let me just share my other screen there. Share the screen.
Additional level of difficulty here because he's actually using a VM or a VNC connection, right?
Yeah, using any desk to compare. Hey, look at that! It connected one shot. Yeah. So just to give you some basis, I'm using YOLO R mixed with Deep Sort. So in my course, YOLO R or YOLO R Pro, I show you how to create this app from scratch. There's a lot that goes into it, training the model with RoboFlow, getting the model, training it, deploying it, and implementing it here. So I'm just going to go into my Python terminal over here and run this one over here. We'll start off with the base file. So this current one is actually implementing it from a webcam. You can see source 0 with the following arguments for the data config file, the new YOLO R weights. This is particular for and specific for Blackjack card counting or just card counting or card detection. We had to rename all of our classes. So instead of the general Coco pre-trained, we gave it the classes of our cards. Confidence of 0.5, image size of 1280, and we are running this on the GPU, and we want to view our image. So I'm just going to run that quickly. Let's cross fingers and hope that everything works. I've got my webcam up here.
So this has been trained on the data set you already shared, right? So people will be able to use that data set to train their own. Yeah,
it's a very robust data set. So it works quite well. Did I press enter? There we go. So this will probably take about maybe 10 to 15 seconds, but it will run in real time.
Mm-hmm.
Dropping a link to the YOLO R course in the chat here for folks who were asking about it.
Cool. Okay, so you can see YOLO R is running at 17, 18 frames per second. It looks a bit laggy through the video because I'm streaming via any disk, and I've got my cards here. So you can see it's picking up ace of clubs and 10 of diamonds. Let me just show you the power of this model, right? So you can see as we move it along, you can see that it's picking up, and it's quite fast. It's quite robust. It picks it up quite nicely.
Yeah, I love the little trails that it leaves when it identifies. It's a very cute touch.
Are you tracking as well, or?
Yeah, I'm implementing tracking as well.
Okay.
It's not necessary, but I like to have it with tracking.
You're showing off.
Why not? Why not?
Yeah, nice,
Uh,
nice.
I'll show off my brandy also one day.
Oh yeah, that too.
Yeah.
um, so I'm just going to quit this application and run the Blackjack app off the bat.
So why don't you tell us what the difference between these two and why they might be the separate apps here.
Oh yes. So in the course, I show you how to create the Blackjack app. So one file will be with just the native card counting app. The second one will be where I show you the logic as to how to implement Blackjack card counting, for example. Like if I bring up a card here, it'll say king, right? It'll count. You can see in the corner over here, it'll show the count. So depending on what it detects, if it's a duplicate, it will eliminate all duplicates, unless if it's a different card, it will sometimes show 10 or 20. So let's try this one here. So it will show 3. If I put in another card, it should show 13. Another card, Blackjack. I actually picked this. Picked this up at random. So this was unexpected that I get Blackjack. Cards. The luck is in my. But the cards are in my favor. If I put these cards up, if it goes over 21, it will say game over, right?
Yeah.
So that's quite cool. Put in another card there. So if it goes over a certain amount, it will just say bust and game over. Otherwise, if you have an ace and a 10, it'll give you blackjack.
Yeah, I love these very simple but like really easy to understand. Everybody's seen playing cards, even if you haven't seen those specific kinds, you have some playing cards in your life somewhere, and so it's really really easy to understand, I think, for folks who are new to this stuff.
Exactly.
So here's the fun thing. The professor or the mathematician who wrote Beat the Dealer, it's slipping my mind his name. Phil, if you could do a Google search. Yeah, sorry. Yeah, anyways, so the person who did, Beat the Dealer for, the card counting.
Thorpe.
Edward Thorpe. So Edward Thorpe he's a brilliant mathematician, right? Who came up with these rules for counting cards. And actually the movie 21 is based on his, the group is not based on his, but the idea that you could count cards easily is his. I mean, he wrote a book on it, and he was actually making money doing that as well, right? Just to show off that you can do it. He was doing it. But there is another tidbit about it. It's not related to this, but I still wanted to bring it up because I don't think I'll get another chance. Ed Thorpe worked with Shannon. Shannon is this giant figure in information theory. He pretty much invented all the framework, the everything in information theory originates from Shannon. So Thorpe and Shannon worked on predicting the trajectory of what is that game called where you throw a ball? I'm sorry, I'm not very
roulette.
Yes, the roulette wheel, right? So in the roulette wheel where the ball would actually land, they were able to predict accurately 30% of the time based on a mini computer that he hid in his pocket. And Shannon actually had a model of the roulette wheel in his garage, which Ed Thorpe and Shannon used to experiment with. And they actually proved that you can predict this thing with very high level. I mean, 30% is huge accuracy. So it's a actually very good book to read, Beat the Dealer, when you get a chance. Fascinating book.
Definitely.
Very cool. Very cool.
This is my demo if Murphy's Law was in action today, but it wasn't. Just shows the card counting in action.
Nice.
But what I really want to show you guys is actually mixing this technology with a projector for projector augmented reality. So I use the same computer vision model and just output the display using OpenCV to my projector. Now you can use any projector for this. The best one that you would rather get is the one with the highest contrast ratio, so you don't get that sort of glare on you. You want it to appear as clean as possible. You don't want any bleeding of the light from the projector itself.
Very nice.
So this was with tracking and that.
I like how you take ideas and present them in such a way that it becomes very, very interesting.
Thanks. Yeah, besides filling that gap between what people learn in university to what they need in jobs, it's also to innovate in the space. So they're not only playing catch up, but they also forward thinking and trying to grasp what they need to do in future, and yeah, basically being as innovative as possible. So I do have courses that I teach, not only on my YouTube channel. I have some free courses there and on my own platform. The main courses that I highly recommend is my YOLO Art Pro. It's got some really great reviews. People are really happy, genuinely happy. We also have sort of like a WhatsApp community where you can interact with other students, and if you need help, want to network or get ideas, they're there to help and share ideas as well. Other courses is my all-in-one computer vision course, which has a mixture of some of these courses as well. CMOS Pro, which is object tracking with segmentation. My YOLO V4 course, which is a bit outdated because we have the YOLO R course, and then I also have a course on mask RCNN. A lot of people are interested in my project either build your own smart glasses AI course. I'll give you more information on that later on. And then also teach courses in augmented reality. Yeah.
And I like how you have arranged your courses into smaller segments, into bite-sized pieces, so that you know it's not you can get a lot by, if you are interested in object detection, the YOLO R course would be very helpful, and you don't have to worry about other things, right?
Exactly. What I would like to do in future is build sort of like a roadmap to say, okay, start here and then build up from there. That's what I still have to do. I think I did some more brandy. My voice is going.
It's not a problem if you lie about it. Trust me.
You'll be the first to know, Phil. Yeah, I also have links to YOLO R Pro, so you can enroll at this link for the free course. YOLO X, you'll be, if you want to build this dashboard, so it's an end-to-end solution from computer vision to user interface and stuff like that. You can enroll in the YOLO X dashboard, but obviously this course is not live as yet. It's still in progress. We're hoping to pre-launch it before Black Friday. There's a lot of work to do, so hopefully we manage to get to it. Yeah. So before I wrap up, I just want to show you guys, mention stuff on my drone. Let me stop sharing. Am I still sharing?
Should we quickly do the question first, so that people who need to leave at 10 o'clock Pacific time can do so?
Yeah, Ritesh, would you please remind everybody what they will win once I ask the question here?
Okay, so we have 5 seats, 5 free seats to the cream of the crop YOLO R course that's currently out there. So 5 lucky winners will win 1 seat each in the YOLO R course.
So we'll just pick the top 5. We'll ask one question, and the first 5 right answers will get the prize, right?
That's right. And so I've got, this one is actually multiple possible answers. So hopefully it'll be,
Oh,
everyone's always so fast every week. So if you've never done this before, the way this works is I'm going to ask a question based on the slides from Ritesh's talk. You're going to answer that question in the Zoom chat window. The first 5 people that answer a correct answer will win a seat to this YOLO art course. Here's the question. Earlier in the talk, there was a slide that showed several other object tracking methods. There were 4 listed, one of which was deep sort. What were the other 3? One of the other 3 is all you need. All right.
wow, that was fast.
Oh, so many.
I guess almost. You guys are close. I see Juan Atkinson, MDNet. That is correct. I see Flavia, MDNet. That is correct. I see Bob Flynn, MDNet. Karen, I see Karen with 2 that are both correct, and I think we have one more, right? I see. This one's taken. Chintan Patel. That is 5. Congratulations, all. Thank you. Wow, that was. I only got through like 10% of the number of answers, but congratulations. Please, if I said your name, send me one email to phil@opencv.org, and we will make sure that you get your seat to YOLO R's course from Augmented Startups. Thanks again, Ritesh.
Okay.
All right, so let's finish the, you still had something to say.
Yes. Let me bring this little
Whoa.
beast over here. So this is the drone that the drone project I was working on. Can anyone guess what this thing is? This device? Put it in the chat.
Right.
The exact model.
The exact model.
Yeah. I'll just move it around here for those.
Yeah, OKD Lite, very cool.
Yep.
Okay.
So right over here is the drone that I built. I got this drone to fly up, just putting my hand gestures up like this. So I did object detection. So when I raise both of my hands, this thing would take off. And if I put my hands down, it would land. And I also got it to follow me along the yaw axis. So there's a whole video on my YouTube channel where I show how to do this with the OpenCV AI kit. I actually used the Oak 1 at the time, and then I switched to the Oak D because I accidentally flew it, and then it landed on wet grass. So it damaged the Oak 1, and then I used this one here.
There's a PoE version which is water resistant, waterproof.
Yeah, but this one didn't have a closure. It was one of the demo models that Brandon sent me. Yeah, it didn't have an enclosure, but eventually Brandon sent me one of these, and I was able to use this. But it was quite heavy for my drone, and therefore, once he sent me the Oak D Lite, I was like more than happy for the weight distribution of my drone.
That's great. Yeah, I love that video, by the way.
Thanks.
Should we open up for questions from the audience?
Yeah, I have one here. Seth would like to know what kind of prerequisites are there for the YOLO courses? What should people know beforehand? Is it required to know any advanced math or algebra or anything like that?
So the goal of the course is to make it as easy as possible, focusing mostly on application of the technology. You could go the academic route, but I prefer focusing on all the different types of applications that you can focus on it. So having that said, you can just have Python and OpenCV background. That's more than sufficient, because everything else I walk you step by step on how to code the apps for YOLO R and DeepSort.
Great, yeah, thanks. Dalton would like to know what, in your opinion, obviously this is relatively subjective, is the fastest object tracking algorithm to use on a Raspberry Pi board at, with a usable amount of accuracy?
Mhm. So the one I used was a MobileNet SSD. I'm not sure of others. I haven't tried others. But the one I used was a MobileNet SSD, and that worked on the drone itself to detect me. I mean, if that worked, obviously I had to train a very robust data set as well. But I was confident enough to command it to fly and land just using using that simple MobileNet SSD. You could try YOLO V3 and maybe even get to
Tiny.
YOLO X Nano or Tiny.
Yes, and there's a new feature on modelplace.ai that will help you compare these things. Would you like to talk about that briefly, Satya?
Yeah, so if you go to modelplace.ai, you can see various models, and some of the models they have been trained on common data sets, especially object detection, and you can see Phil, if you have it in front of you, you can share the screen. You can see the performance of various models in the same place. And when I say performance, I mean how fast it runs, what is the memory, what is the footprint of the model, and two more things. uh, yeah, could you move down?
Yeah, I just shared my screen here, and so we're
Yeah.
looking at the YOLO X here, and if you scroll down here, you will see comparing this model with others. Go ahead, Satya.
Yeah, and you can see here, your tiny YOLO V3, there are two axes. One is speed and the other is accuracy. So ideally, you want something which, which is very high quality, right? And also, high speed, right? So you will see that, the tiny versions of these things, there is, the quality versus speed, you can check which one is better, right? And here you can see that, oh, the speed of YOLO V3 is actually higher than YOLO V4, right? And the accuracy is lower, right? So, and then you can also look at the footprint of this model. If you look at, the size of the model, the bubble size, it actually represents what is the size of the model. So that way you can compare, oh, this one is not appropriate for Raspberry Pi. You should probably go and use a tiny version or, MobileNet version of an object detector.
Yes, and that feature on ModelPlace is available for pretty much any of the models that have similar functionalities as each other. It's really, really helpful when you're trying to decide what to even try first, because it makes sense to maybe try multiple things sometimes. I think we got time for about one more question here. Kumar would like to know, how does tracking your cards in the demo application there affect the performance? Did it actually measurably drop the frame rate, and if so, how much?
It was, say, around 4 frames a second. So maybe I would get a frame rate of maybe 20 to drop like maybe 4 to 5 to around 15 frames a second. So that was just on the card data set. But for other data set, it varies. But I found Deep Thought to be a little bit. I thought it was going to be quite intensive, but it was not that bad running it.
And with cards, actually, you could use a non-deep learning model also, because it's so easy, right? The signature, the appearance is so easy that you could use one of the trackers which are present in OpenCV, and they'll do fine, right? In fact, you could do a very simple pattern matching kind of thing, and they will also be fine, right? So there are approaches which you can speed up tracking quite a lot in this scenario. Not always, right? Deep learning usually is much better, but in this case, you may be able to use traditional computer vision techniques.
I'd like to see a bike track on modelplace.ai, and also maybe a tracking comparison as well. That would be cool.
Right.
Like with Deep Thought and also Fairmont. That'll be quite interesting to see.
Right.
Great idea. Definitely. Before we have Satya take us home, how can people best get in touch with you, Ritesh?
The best way to can get in touch with me is on WhatsApp. That's actually have a nice computer vision WhatsApp community, not just for the YOLO R people, but also for anyone interested in computer vision, AI, and drones. Let me just see if I can share my screen for the last time and show my links there. Yeah, so you can head over to my website, augmentedstartups.com. Also check me out on WhatsApp, augmentedstartups.info/WhatsApp. And if you want to connect with me on any other social platform, it's basically this first part, augmentedstartups.info/LinkedIn, Facebook, Twitter, and YouTube, obviously. So I made it quite simple for everyone to connect with me.
Nice.
All right, that's great. Go ahead and unshare your screen here since we're closing it down. Thanks so much for joining us here. Satya, you want to take us home?
Yeah, I have a couple of announcements before we leave. The first one is OpenCV AI competition. The new OpenCV AI competition is already on, if you don't know. So please go and check it out. It is based on OpenCV AI kit with Depth Light, OGD Light, and Legos. You use Legos to build some manufacturing solution along with OGD Light, and Phil will share that information here. Also, OpenCV Python course is free until November 14th. So please, if you're a C++ developer, need help with Python, or you have been using Python but you don't know the Pythonic way of coding, so we got an expert in Python who teaches this course. It is free until November 14th. So please, take it for free while it is available. And so that's about it. I would like to thank Ritesh for putting this together very quickly. Thank you so much, because you saved the day for us. And
Pleasure's all mine, Satya.
Thank you. And Phil, thanks for organizing this. Really appreciate it. And as always, our audience, thank you so much. You really mean a lot to us. This keeps us going. Thanks.
Thanks, everybody. Next week, our guest will be Team Cerebros, the third place winner of OpenCV Competition 2021. Same bat time, same bat channel, 9 a.m. Pacific. We hope to see you there. Thanks so much for watching this episode of the webinar. Please hit that like button, subscribe, and don't forget to tap the little bell icon to be notified when new episodes drop. This week's episode was brought to you by OpenCV Courses. Learn computer vision from the experts at opencv.org/courses. If you'd like to be in the audience next week, subscribe to the OpenCV newsletter.